In this video, let's try to look at the last two password encoders that's provided by Spring Security Framework, which are Bcrypt and Scrypt password encoder. So Bcrypt password encoder is the most commonly used password encoder these days in any web application for hashing mechanism, especially for passwords. So this follows Bcrypt strong hashing function to encode the password, and you can create this encoder by following any of these three constructors. The very first one is which is a default constructor, followed by a second constructor where you can mention the coefficient value which represents how many times the encoding process has to go through in terms of logarithmetic. So if I mention 4, that means internally it will go to the 2 power 4 of rounds for the encoding process. And at the same time, you can leverage the third constructor where along with the coefficient value, we can also pass the secure random instance to generate a random solve for your hashing mechanism. Though Bcrypt password encoder will solve most of our problem, but as we pass day by day, the hackers also are getting stronger CPUs, stronger GPUs, processors, which can help them to derive the original text by comparing hash of each and every text available in the dictionary. So to avoid that, we have a recent password encoder, which is a Scrypt password encoder. It has so many parameters accept, which not only will take exponential time of the hacker to decode your hash, but also it will take the exponential memory of the CPU whoever want to decode the password hash. So due to that reason, you are free to use Bcrypt or Scrypt password encoders, and these should solve our password problems and the way that we store inside the database for any web application. Compared to the previous password encoders which we discussed, these password encoders are pretty strong in nature, and any hackers need lots and lots of time and memory and processors in order to decode these hashes, which is almost impossible in the current situations. So in the Scrypt password encoder also we have two constructors where we can create this. One is the default constructor and the second one is a constructor where it accepts 5 parameters. So we'll see what are these 5 parameters by going into this code. First, let's try to go and see what is the Bcrypt password encoder. Bcrypt password encoder, as I said, it has a simple constructor, and at the same time it also has a constructor where we can pass the strength of the coefficient in terms of log rounds, and it ranges from 4 to 31. And Bcrypt also has various versions. So that's where we have a constructor which can accept the version, but I think we don't have to use this. We should, as a developers and architects, we should always worry about the strength and the default constructor. And by default, the 2A version is used by the Spring framework. But if there is a scenario where you want to change this version, you can always go and use the other versions that we have, which is 2Y, 2B also. Suppose that we also have encode method where it will call internally Bcrypt library to hash the password by passing the raw password and the salt associated to it. And at the same time, we also have a matches implementation where it will try to check the password by passing the original password and at the same time encoded password. So inside this, the original password will be hashed and it will try to compare with the hash value that we maintain in the database and what we calculated from the user input value is equal or not. Based upon that, the matches will return a boolean. For that, we also have a Scrypt password encoder. And as I was saying, it has a default constructor. Though we are mentioning the default constructor without passing any parameters, it internally uses the same numbers which I have shown previously because these are the default numbers that this password encoder considers. Let's try to see what are these numbers. The first number considers CPU cost. What is the CPU cost that you want to leverage to generate hash, and memory cost, which is the second parameter, and the third one is a parallelization. So how many parallel cores you want to use, and fourth one is a key length that you want to generate, and last one which is the salt length that you want to generate. So considering all these parameters, The Scrypt password encoder is most powerful compared to any other password encoders because it's not only takes exponential time of the hacker but also exponential memory of the hacker processor or any CPU, GPU that hacker is using. So with this, we have discussed enough of theory about the password encoders. In the next video, let's try to make code changes to our application to use Bcrypt password encoder, considering that is the most commonly used password encoder these days. That's why I want to show you hands-on how to implement any of the password encoder, which is in our scenario Bcrypt password encoder. Thank you and see you in the next video. Bye.